All right, gang, this is Mr. Spencer, and today we're going to talk about how I wasn't the brightest sixth grader ever. Actually, we're going to talk a little bit about acceleration calculations through some of the stupid things that I said when I was in sixth grade. So let's get going. What we're going to do is we're going to talk about two different equations that we can use when solving problems related to acceleration. Now, the first one is this idea of v equals at, or in other words, the velocity of an object equals its acceleration multiplied by the time that it's been traveling. So we'll talk a little bit about how that works. The other one that we're doing is this equation which d equals 1/2 at squared. In other words, the distance an object travels equals half the acceleration multiplied by the time it's been traveling squared. So let's go over a few assumptions in these examples. First of all, in these examples, the object is starting at rest. It's 0 meters per second. It's not going anywhere, or it's not moving anywhere at the time. Also, the direction of motion and the direction of acceleration are the same. In this case, it's a positive acceleration because it's speeding up. Now, this is going to be more important in other videos when we start talking about when things are slowing down. And also, just a little reminder of something that we've talked about before. Acceleration due to gravity, and when something's in free fall, when gravity is the only thing that's causing it to accelerate, we call that little g, or 9.8 meters per second squared, about 10 meters per second squared or so. But let's dive into this. So here's way back when I was in sixth grade, we had a field trip to Toronto, and one of the things that they did is they took us to tour the CN Tower. Now, the CN Tower itself is about 553 meters off the ground. Now that's way at the top there, but you notice that little bulb in the middle? That's called the observation deck. And they took all of these sixth graders up to the observation deck. And of course, me being the idiot that I was back in sixth grade, and pretending to know a whole lot, I said, you know what? I heard that if you take a green M&M, or it had to be a peanut M&M, green peanut M&M, and drop it off the CN Tower, it would go through the roof of a car. Like I said, I wasn't the brightest kid in the world back in sixth grade, but you know, when you're a kid, you say stupid stuff. But let's take a look at dumb things I said and see if that's really the case. So here's our first example. Now let me get my pen up and running here. Make sure that we've got the right color. Come on. All right, so here's what we've got. So if sixth grade Mr. Spencer were to drop a green peanut M&M, once again, I have no idea why it had to be a green peanut M&M, but that's just what I said. From the observation deck of the CN Tower, it's going to take about 8.4 seconds to hit the ground. And we're playing pretend here. We're assuming that there's no air resistance. Now, how fast would that be traveling when it hits the ground? All right, so here's what we're going to do. We're going to plan a little bit, and we've talked about this before, but we want to figure out first, what are we trying to find? Well, we're trying to find how fast. Okay, so how fast is velocity? So that's what we're looking for there. Now that we know what we're looking for, let's talk about what it is we have already. So if I'm reading this, I see, okay, it's going to take 8.4 seconds. All right, so time is equal to 8.4 seconds. Now, there's something else that we know, but it isn't written in here. If I drop that green peanut M&M and it starts falling, that's in free fall. So that means it's accelerating due to gravity. So in this case, acceleration, or because it's acceleration due to gravity, we're going to write that as little g. That is equal to 9.8 meters per second squared. All right, so that's going to be important because a lot of times it's just we're going to assume that you know that. All right, so we're trying to find velocity. We have time. We have acceleration. Now, how the heck do we solve this? Well, it's going to be velocity equals acceleration. In this case, it's acceleration due to gravity, so we write it as g, times t. So if I go and solve this, I've got, all right, 9.8 meters per second squared multiplied by the time, which in this case is 8.4 seconds. And if I get out my calculator and do this, I am going to find that it is right about, what is it? 82, that's supposed to be an 8, by the way, 82 meters per second. All right, so remember, so I said that it would be able to travel through the hood of a car. All right, just so you can kind of compare this, if it's going 82 meters per second, it definitely would hurt if it hit you. But just if you're shooting a gun like a 22, like one of those little itty bitty guns, that bullet is traveling at about 370 meters per second. So compare that to 82 meters per second. It's not going through the roof of a car. Like I said, wasn't the smartest kid in 6th grade. All right, next one. Same setup, but this time, how far off the ground is the observation deck? Now remember, I said that the CN tower itself was like 553 meters tall, something like that. But the observation deck is kind of like right in the middle. So how would we figure out how far off the ground that observation deck is? Well, same thing as before. This time we're trying to figure out what it is we're looking for. See if I can actually get this to work. There we go. Okay, so this time we're trying to find distance. That's our question mark. Same thing, we know that time is equal to 8.4 seconds. And we also know that the acceleration, in this case acceleration due to gravity, is 9.8 meters per second squared. So if I'm going to try to find distance in this case, I'm going to use the equation distance equals 1/2 acceleration. Remember, acceleration is due to gravity, so we're going to do that. Gravity times time squared. So if I solve this, I've got 1/2 times 9.8 meters per second squared. And I really wish I could write today. But the time is 8.4 seconds, and we're squaring that. So if I go take 1/2 times 9.8 times 8.4 squared, and I do that, I get 346 meters. That's supposed to be a 6. But if I'm doing sig figs, okay, I've got 2 sig figs here, 2 sig figs here. I'm going to round that off to 2 sig figs. So we're at about 350 meters. All right. So once again, we were ways up, not far enough to be able to drop a green M&M through the roof of a car. But hopefully now that makes sense. We've got those 2 different ways that you can solve acceleration problems, and hopefully you can go and solve some of those. Let me know if you have any questions.